This is unit number 3, video number 12, Lewis structure summary. So to summarize Lewis structures, obviously you got to figure out how many valence electrons are there. The number of valence electrons is the number of electrons that are drawn in your picture, whether bonds or dots. They must be identical, because that's the number of electrons that the atoms are using in their bonding. The core electrons are just stabilizing the atom. They're not involved in the bonding. But the bonding is created by the valence electrons, it's outer shell electrons. Got a little chart here just to show you some generalizations about some of the columns. And these are the columns, not just this element. So carbon's column, which would be really silicon, would be the other atom. Nitrogen's column, which would include phosphorus and arsenic. Oxygen's column, which would include sulfur, selenium, and tellurium. And then fluorine's column, the halogens, which would include chlorine, bromine, and iodine. The number of valence electrons we know how to determine. So the entire column has 4, nitrogen's 5, on and on and on. This here is the number of expected bonds. It's not a hard and fast rule. I can show you examples of carbon that has triple bond, but not many. I can show you examples of oxygen has triple bond, but not many. Or oxygen only has a single bond, again, but not many. So we expect carbon to have 4 bonds. It's missing 4 electrons. It wants 4 bonds. If I drew the Lewis structure of the atom of carbon, it would look like this. That shows that I'm missing. So it shows the 4 areas that I would expect bonding to occur. Nitrogen has 5 valence electrons. We expect 3 bonds. Again, not a hard and fast rule. I can show you exceptions. But most nitrogen compounds are going to have 3 bonds. So nitrogen's Lewis structure would look like this. Boom, boom, like that. So now you can see there's clearly 3 bonding points for nitrogen. Something has to happen moving valence electrons to have something other than 3. Oxygen, we have 6 valence electrons. We expect 2 bonds. Again, there are exceptions, but primarily we would expect oxygen to have 2 bonds. So having 6 electrons, oxygen is going to look like this. And so we have 2 bonding points here. Okay? Fluorine's column, the halogens, have 7 valence electrons. We only expect 1 bond. Again, there are exceptions, especially when the halogens are bonded to oxygen. But in other cases, there's not going to be. So we're expecting 1 bond there. So fluorine, 1, 2, 3, 4, 5, 6, 7 electrons, and only has 1 bonding point. Okay? Now, one of the things we want to be aware of when we talk about the number of bonds. A triple bond is shorter and has more energy than a double or single bond. So to create a triple bond, the atoms have to scrunch up closely, and we'll look at when we do geometries the type of overlap that occurs there. A double bond is longer than a triple bond, but still shorter than a single bond. More energy, the energy sits between the 2. And the least energy is a single bond, and it is the longest bond. So we're going to be aware of that. That'll be true for any atoms when comparing the same bonds. A triple bond is shorter than a double bond, which is shorter than a single bond. Okay? An example of, here it is, COF2. Let's draw this structure, and we'll see when something looks like it has resonance, but it really doesn't. So carbon here is going to be the central atom. This is one where you look at it, you might think oxygen's going to be, it's not. The least electronegative element is going to be in the center other than hydrogen. So carbon's going to be in the middle here. So we're going to have C to O to F to F. Valence electrons, 6 plus 4 is 10. Each fluorine has 7, that's 14. 10 plus 14 is 24. So 24 valence electrons. I've already drawn 6. So I have 18 electrons available to complete the octets. Well, you can see the carbon here is going to need 2. Each of the outer elements needs 6. 6 times 3 is 18, plus 2 is 20. So I need 20. This tells me I need to add a bond. You'd ask, where am I going to add that bond? Because it looks like there's 3 equally likely places. But if we go back to our expectation for the elements over here, we know fluorine and the halogens only really we expect to have 1 bond, whereas oxygen we expect to have 2 bonds. Again, not a hard and fast rule, but definitely a strong expectation. So if the electrons can do that, they normally will. Okay, so here we wouldn't have a double bond to either of the fluorines. We'd have a double bond here with our lone pairs, and now we've got everything happening. Carbon has 4 bonds, that's what carbon wants. Fluorines each have 1 bond, that's what they want. Oxygen has 2 bonds, that's what they want. That's going to be the most stable structure. There is no resonance.